touch that. All right. So yesterday we looked at the exponential equation. And maybe you stumbled upon the general form of the exponential equation. And we're going to go into that in more depth today. And the general form is a times b to the x. Okay. Now, oftentimes we're given some data points like this, or a table of values, and we want to find a and b. Now, just looking through this table of values, I noticed that between here and here it goes up by 4, and between here and here it goes up by 6, and between here and here it goes up by 9. So I know that it's not linear. So maybe there's a constant multiplier instead of a constant, something that's being added to it each time. So I'm going to go look at the general form and see if that's going to tell me anything about where I might find my a and b. So let's come over here. There's my general form, y equals a times b to the n. If I plug in 0, I get a times b to the 0 power, okay? Which is the same thing as a times 1, or a. So my 0th term is always going to be a. So let's go over to this one. My 0 term is 8. So I know that a equals 8, just because it's the 0 term. All right, let's move on down. Let's keep plugging away. So I plug in 1, and I get a times b to the 1, which just equals a times b. Plug in 2, I get a times b to the 2nd. I get a times b times b. A times b to the 3rd, which is a times b times b times b. Now what I notice is that I take the previous term. In order to get the current term, I take the previous term and I multiply it times b. Okay? So let's look at that just a little bit. Let me give myself a little room here. Okay? So let's call the nth term is the current term. Okay? And in order to get that current term, I take the n minus 1th term and I multiply it times b. Okay? To get that current one. So in order to solve for b, all I have to do is divide by that previous term, the n minus 1th term. So nth divided by nth minus 1 is going to give me b. The other way of saying that is the current term divided by the previous term will equal b. So let's go back over to our example here and look at that. So let's take 12 and divide it by 8. 12 divided by 8 equals 1.5. If you don't believe me, you can put that in your calculator. And then I'm going to take 18 and I'm going to divide it by the previous term and say 18 divided by 12 equals 1.5. Then, let's just to do one more just to make sure, I'm going to take 27 and I'm going to divide it by 18. And I get 1.5. So because those are the same, I know that this is an exponential function, and this is my b. So now I can write my equation, y equals a, which is 8 in this instance, times 1.5 to the x. And there we have it. So let's go down through the notes and see what else we got. So we know that a is always the 0 term. So when I plug in 0, I will get a. And exponential functions grow by a given percentage. And we find this percentage by dividing the current term, or the nth term, by the n minus 1th term, or any term by the previous one. For example, and then we have that example up there. A is also synonymous with the start amount, and B is the constant multiplier, or the percent change. Now, sometimes we're not given, so when we look at, let's look at a bunch of them, and we're going to look at it in terms of this over here, which is y equals a times b to the x. So let's go to the next page here. You guys can flip over. Now, y equals a times 1 plus r to the x. Okay? Where a is once again the start amount, and r is the percent rate of change. Okay? Given any value of a, we can find the percent change by finding the difference between b and 1. For example, let's say I was given this equation here. Y equals 1.25 to the x, where this is a 25% increase. In other words, r is 0.25, or 25%, because b equals 1 plus r. So if we subtract 1, then whatever b minus 1 is going to tell me what my r is. So in this case, 1.25 equals 1 plus r. Subtract 1, and you're going to end up with 0.25 equals r. And so this would represent a 25% increase. Let's go to the next one. The difference between 1.75, so here's my 12 times 1.75. Well, the difference between 1.75 and 1 is 0.75, so that would be a 75% increase, because r is 0.75. Okay? Those are usually pretty obvious when it's greater than 1. It gets a little trickier when it is less than 1. So if I know that 1 plus r equals 0.95, as in this next one, okay, then when I subtract my 1, r equals 0.05, negative 0.05. So this would be a 5% decrease. Okay. Here, this next one, 2 million times 0.75 is a percent decrease. Well, let's see. 1 plus r equals 0.75. I'm going to subtract 1 from both sides, and I get r equals negative 0.25. Now we know that that 0.25 is a 25% decrease, okay? Because r is negative 0.25. So we're always looking for that difference between the b and 1. Now let's go back to our original example. Y equals 8 times 1.5 to the x. Well, the difference between 1.5 and 1 is simply 0.5. And we know that 0.5 is the same thing as a 50% increase. Enough about that. Let's go to the next page and do a quick example, and then that'll be it for the day. Now, sometimes we're given information and we're just asked to plug it in. So for example here, most automobiles depreciate as they get older. Suppose an automobile that originally cost $14,000 depreciates by 20% each year. So $14,000, that's going to be my start amount. So I'll say y equals 14,000 times, now that's my 20%, it depreciates by 20%. So I'm going to use the y equals a times 1 plus r to the x formula. And I'm going to plug in that 20% in for that. And I know 20% is the same thing as multiplying times 0.2. and it's a decrease, so I'm going to make it negative. So I'm going to say 1 minus 0.2 to the x. So now I have my exponential equation. Okay. What is the value of the automobile after 2.5 years? Well, 2.5 years, so that's 2.5. Now, let's think about this. So if y equals the value of the automobile in dollars, and then x is years, okay? Then let's look at, so where would I plug in that 2.5? I can say y equals 14,000 times 1 minus 0.2 to the 2.5. And at this point, all I have to do is plug that in my calculator. So I'm going to go in there, and I'm going to say, go to my home screen, clear it up, and say 14,000 times, parentheses, 1 minus 0.2. And then I'm going to use this to the key right here, to the 2.5. You'll see I get 8,014, and since it's money, I'm going to round it to the nearest dollar. So that would be 0.07. Close this up, and that equals 8,014.07 cents. Okay. Now, when is it going to be worth half its initial value? That's when it gets a little tricky, a little trickier. But pretty much you're just going to plug it in your calculator and guess and check a little bit. So I can go in here and I can type it in and turn all this stuff off. Okay. And I'm going to type that in, 14,000 times 0.8 to the x. Okay. And let's go to my table and see what I got. So there you can see I start out at 14,000, and I want to know when it's half. So somewhere, you can see somewhere between the 7th year and the third year and the 4th year, it's worth about that much. It's worth half as much. So we can just estimate that and say, well, let's say between 3 and 4, okay, between 3 and 4 years, the value will be $7,000. And that's good enough for now. We'll put 1 too many zeros.